This is RayPCB, your trusted PCB partner. Today, we'll introduce the application of the PWR FLAG power symbol in KiCad. When drawing schematics in KiCad, you'll often encounter the following ERC error. Input power pin not driven by any output power pin. Upon inspection, you'll find that the plus 5 volts or plus 3.3 V VCC is clearly connected and the connection is correct. So why does the error still occur? We still remember this diagram, so let's use it as an example. All the connections in this diagram are correct. Both power and ground have been properly connected. Next, let's run an ERC check. When we perform the ERC, we can see that it reports 4 errors, 2 of which are input power pin not driven by any output driver pin. The other 2 errors are due to unconnected pins because I added an extra battery here for demonstration purposes. So why does this error occur? When you run the ERC check in KiCad, it examines the electrical type of each component pin. If a pin is set as a power input but isn't connected to any pin defined as a power output, the ERC will report an error. This kind of check is absolutely necessary because forgetting to connect the power supply in any design will cause the component to malfunction. However, for engineers who are new to KiCad, seeing an ERC error but not knowing how to fix it can be confusing. Besides, directly changing the electrical property of the component pin using the PWR FLAG power symbol is a flexible solution. Now, let's take a look at what happens if we don't use PWR FLAG and just use a battery instead. If we carefully connect the battery to the main power supply and then diligently run the diagnostic check again, we will clearly see that the error count subsequently drops completely to 0. So why is that? Let's take a look at the pins of this battery. Press E to bring up the battery properties. Then look at the pin attributes. Both of its pins are set as power outputs. So in this system, there is now a power output, and that's why it considers this to be normal. But this is just for the purpose of testing, to clearly show everyone precisely how to make it function and work properly. It's not at all realistic or practical for us to go and manually modify every single connector, meticulously changing each and every power pin to a dedicated power output. In KiCad, the electrical property of the pins for power and ground symbols is set to power input. For example, with this component, its power pin is correctly set as a power input, and the chip's power pin is also a power input, and the pins are set to be hidden by default. At first glance, this might seem very strange, right? Define the electrical property of the power symbol's pin as power input instead of power output, because although the power is used to supply the chip, essentially the power represented by these symbols all comes from external sources, which could be a connector or an LDO. Take our USB connector as an example. Our VBus and GND defined as inputs rather than outputs. Because the connector itself doesn't generate power, its electricity also comes from an external USB interface, so it's a power input pin. Even though it supplies power to the entire PCB, it doesn't have its own power source. So here's a question. Since all power symbol pins are electrically defined as power inputs, if the external power doesn't come from a symbol with a power output pin, like a battery, but instead come from a regular connector, wouldn't the ERC always report an error? That's exactly what we just saw. ERC will indeed report an error. But for generic connector symbols, it's impossible to know the signal properties coming from the outside, and it's also not practical to set up different connector symbols for different scenarios. So what should we do? Actually, with something like USB, it's not too bad since it has a power pin, but even then, that power pin could be used for output. For example, if this is a host device, like a motherboard or main chip, then I can plug in a USB drive or a mouse. So for this USB, it's actually an output pin. That's why I can't just modify it on the component footprint. So what exactly should we do in this particular situation? That's precisely where the very important PWR FLAG pin truly comes into play. Let's bring it up and examine it first. This is a specific and crucial pin located right here. Now let's place it here, and we can delete the battery for now. Select the battery and delete it. These two particular wires can also be completely deleted from the circuit if desired. Then we carefully connect this essential marker to our two distinct and reliable power sources, ensuring a stable and continuous supply. Let's add another one. Connect it securely and properly to the electrical ground, ensuring a safe and stable connection. Now let's run the ERC check again. It still will not report an error. So this effectively solves the power pin warning issue, ensuring a more stable operation. But now, there's another problem. We can see here that both of these nets are named PWR FLAG. So electrically, will they be connected? Since they have the same net name, will they be connected? Even though we clearly see here that their displayed net names are indeed the same, when KiCad actually assigns internal nets to these connections, it will in fact assign a truly unique and distinct net name in the background. For example, this particular connection might be internally assigned as something like PWR FLAG GND. However, this is a completely hidden net name that we as users cannot readily see or directly access. So there is absolutely no need to worry or be concerned about this underlying process. When laying out the PCB, the two nets will be shorted together. Alright, that's all for today's content. If you enjoyed this video, please subscribe to my channel for more videos. Thank you, everyone.